Lecture 24. In this lecture, we're going to talk about phase diagrams. So what's a phase diagram? A phase diagram is just a diagram that shows the phases. Okay, so here's an example of phase diagram for carbon dioxide. Here it shows you the solid phase, the liquid phase, and the gas phase. So let's talk about how phase diagrams are actually created. So here's an example of how a phase diagram for water is actually created. So here we have water with no air in it. Then we heat it up. So what happened is as the water is heated, it's going to turn to vapor. And when it turns to vapor, it's going to basically push up this, creating an area of gas. And basically all that data, the vapor pressure, the amount of water, and how much heat is all regulated and controlled. And so we can basically measure it. And so we can come up with a diagram. So here is a chart of temperature versus pressure. So now notice that here is the line that separates the liquid form of the water and the gas form. Okay, so as we heat liquid, it becomes a gas. So notice as the temperature goes up, okay, we're getting more and more gas. So this line here represents the change from a liquid to a gas. Okay, so if you're on the line, then you're both liquid and gas. That's the part where both liquid and gas are there. But if you over the line, now you're a gas, or if you're back on this side, you're liquid. Now, they did it again, but this time between a solid and liquid. So basically, they're going to freeze this, right? They're going to take energy out. So notice the temperature goes down. As the temperature goes down, we go from a liquid to a solid. So again, on the line, you have liquid and solid existing together. If you're here, then you are liquid. If you're here, you are a solid. Now, notice the negative slope. Okay, the negative slope means a substance will liquefy, meaning it will change from a from a solid to a liquid. Okay, so as you add heat, notice if you add heat, it goes from a solid to a liquid. That makes a lot of sense, right? Okay, now this line is a line that separates, notice, the solid into a gas. Okay, we have three phases, right? Solid, liquid, gas. So here's a line that goes from a solid to a gas. So if you're here, you have a gas. Here, you have solids. Here, you have liquid. Now, this point right there is called a triple point. That triple point is a point that if you're there, okay, if you are at this point, then all three phases of matter exist. So at this point, you have solid, liquid, and gas. So every phase diagram will have this triple point. It will move and it will change depending on the substance that you have. So again, a triple point is a condition between temperature and pressure where all three phases of matter exist in equilibrium. Okay, so this is a very special point. A triple point is where all three phases of matter exist in equilibrium. Now, at the top of the liquid gas phase there's this point called the critical point. Okay, so this is the critical point. This is called the triple point. That's the critical point. Now, the critical point is the temperature beyond the critical temperature and pressure beyond the critical pressure that the entire system become what we call a supercritical fluid. Okay, so supercritical fluid is one of those strange things in nature. It's too dense to be a gas, okay, which means it's not a gas. And it's not dense enough to be a liquid, which means it's not a liquid. So at this phase, we don't know what we have. We're not a gas and we're not a liquid. Okay, we have something called a supercritical fluid. And of course, we're not going to go so deep into this to figure out what those are because it's a really hard concept to understand. Now, let's take a look at the phase diagram for carbon dioxide. Now, notice carbon dioxide has a positive slope. Okay, so positive slope means if you increase temperature, yeah, you're going to get it turned to liquid, but it's not going to do it very well. So if you increase pressure, however, it will solidify. It will basically go from a liquid to a, from a solid to a liquid. Now, here's the critical point. Here's the triple point, and there's the critical point. Okay, so notice the slope. Okay, so now notice here's solid, here's gas. Okay, so notice something very, very special. Notice at 1 atmosphere, that's where we are on Earth, right? At maybe 1 degree Celsius, which is around here, notice that at 1 atmosphere, the solid turns right into a gas. Okay, liquid carbon dioxide solid carbon dioxide is called dry ice. And if you've never known dry ice, it turns from a solid to a gas in what we call sublimation. So if you notice, here's 1 atmosphere. This is where at sea level. 1 degrees, let's say it's right here. So if we have a piece of liquid nitrogen, liquid carbon dioxide, a solid liquid carbon dioxide, dry ice, here it will start to heat up, and notice it goes from a solid to a gas. It does not turn into a liquid. That's why we see the properties of solid carbon dioxide or dry ice. So here's an example of the question you might be asking. Describe the phase change that occurs if CO2 is kept at negative 52 degrees while the pressure increased from 1 to 50 atmosphere. So all we have to do is we go, okay, we're going to keep it at 52 degrees, right? So 52 degrees negative, it's probably about right there, all right? So now if we increase the pressure from 1 atmosphere, right here, to 50 atmosphere, which is, let's say right there, what's going to happen? Well, as we increase the pressure, it's going to change from a gas into a liquid, then from a liquid into a solid to go up to 50 atmosphere. Okay, so it's pretty easy to understand, right? So we just have to read, and where it lands tells us what phase it's in. So here we see it again. So in phase 1, the increasing of the pressure turns the gas closer and closer and closer into a liquid at that step. Now at step 2 right there, liquids and gases exist together. Then in step 3, all we have is liquid. The liquid is getting compressed together closer and closer and closer until we step 4. In step 4, we have liquid and solid coexisting. Then of course we increase the pressure to step 5, and basically when we get to the top of step 5, all we have now is solid only.